So in the individual gas laws we have talked about so far, we had one dealing with pressure and volume, that was Boyle's law. We had one dealing with volume and temperature, that was Charles' law, but we haven't yet investigated a gas law that involves just pressure and temperature. That's where the Gilusak's law comes into play. Gilusak law involves pressure and temperature with volume constant. So for Gilusak's law, pressure and temperature are directly proportional. So that means P1 over T1 is equal to P2 over T2. So to do problems solving using this individual gas law, you'd attack them in this way. Let's say we had a quantity of gas with a particular pressure at a particular temperature, remembering that we still need to convert our temperatures to Kelvin. But we have a P1 and a T1. We need to know what the new pressure is at the new temperature. So we organize our variables. There we go. Sorry, we organize our variables this way, making sure we convert our temperatures to Kelvin. And then we need to solve Gilusak's law for the variable P2. And so hopefully you can see that by cross multiplying and dividing, P2 is going to equal P1 times T2 divided by T1. Then now you're at the point where you can substitute in the values that you were given in the problem. And then you can, I would tell you to set them up so you could see your units cancel. You're going to be left with something in torr, which is what you're looking for. So when you do that multiplication and division, your final answer should be 824 torr. And that makes sense that the pressure would increase because the temperature has increased as well. And pressure and temperature are directly proportional. If you increase one, the other one increases as well. So that is Gilusak's law. Last individual gas law that we're going to talk about is Avogadro's law. And yes, this is indeed the same scientist from Avogadro's fame with moles. So I guess it makes sense that his law involves our favorite unit, the mole. Just like we saw that volume and like we saw that Gilusak's law with pressure and temperature being directly proportional, Avogadro's law is a direct proportionality, specifically volume and number of moles. And that sort of makes sense. The more stuff, the more moles of a gas you have, the bigger volume it's going to take. So the gas law, Avogadro's law, that you'll use for this problem will be V1 over N1 is equal to V2 over N2. Initial volume, initial moles, final volume, and final moles. So this would be a representative problem that you would encounter to solve. Let's say we had a particular sample, so we have an initial volume, and it contains that many moles of gas. I want to know how many additional moles I need to add to get a final volume of 6.4 liters. So when organizing my variables, I see that I have a V1, 4.8 liters. I have an N1, 0.22 moles. My V2 is 6.4 liters. My N2 wasn't given, and that's what we're going to be solving for. But we need to remember that the problem wanted to know how many additional moles we're going to add. So to solve this problem, we're going to solve for N2, but then we need to subtract 0.22 moles from that, because what we're really interested in solving is this additional moles that are added, X. But let's go ahead and solve for N2, and once we find N2, we subtract 0.22 from it, and that'll give us the amount of additional moles needed. So we're going to solve for N2 by cross multiplying and dividing. And hopefully you can see that N2 is going to be equal to N1 times V2 divided by V1. Go ahead and put in your values that you were given. See your units cancel appropriately, so you're left with moles. So when you put that in your calculator, you will get 0.29 moles. That is N2. It's not the final answer for the question, because the question wanted to know how many additional moles had to be added. So I take my N2, which was 0.29, and I subtract my N1, which is 0.22, and that gives me my answer as to how many additional moles are needed to obtain the volume that I want. So those are the kinds of problems that you will use or that you will encounter with regards to Gilusak and Avogadro's law.